Hello everyone, it's a pleasure to welcome you all for my mathematics class. Today I am going to take up the network scheduling in the sense that your work simply cannot be performed. It has to be divided into activities, sub-activities, and all the activities in consolidation or put together will form the project. So in simple words, a project is nothing but composition of activities which have to be performed in a certain order, in a sequential order, so that it will become a real project of worth. So you see that means a project will have number of activities involved in it, and every activity has a logical reasoning with the preceding activities and also the succeeding activities, and it is connected in some way or other, that it has to be performed only in that way in order to achieve the goal of completing the project with satisfaction. So this is, so for which a network you have to form, you have to draw the network of the project, and proper scheduling must be done. That means it must be properly scheduled. Your work involved in the project must be properly scheduled, and you have to draw the network as per the logical way of performance of the activities, so that the project will be completed in time or before time. Otherwise, there is every chance that it may exceed the duration of the time you have set as a goal, or that the expenditure on the project which you have fixed will be for exceeded because of the time delay. So this is the idea. So you have practically, you can find that some of the government projects which have been started and delayed for years has resulted in enormous increase in expenditure, and that the work will not be, and there will be a lot of defects in the work. So in order to avoid defects in the work and to avoid the escalate, that is a cost expenditure going very high, and also to finish in time, this scheduling, networking are very important. So that is what we are going to see in this. So you see this in this, see, it is a deterministic project in the sense that every activity has got a fixed time of finish. It is a deterministic activity, and therefore you can say that the project will be completed in 6 months or 1 year or 3 years, like that. Okay, now here is it's a building. It is you are constructing a building or you are constructing a bridge. So you see that you are giving a scheduling for the activities, and you draw the network. I will show you the network, and you see that as per that you go and you execute the project as per the activities, as per the scheduling. So you see that your project may even be completed before time, a little before time, and if at all, if it exceeds, marginally it may increase. If you don't do this, then you see that you will not know when you will finish, and the expenditure will become very huge. So in order to avoid those problems coming, we see that we give a scheduling, we draw the network, execute the project as per the scheduling given in the network. So that is what we do. So you see that in this, so here you are given the 1, 2, 3, 4, 5, 6, 7 activities are there. These 7 activities are the activities involved in the given project. there is a project, and in which these are the 7 activities which are given, and you see that the scheduling is done. The duration of the activities are given. The duration of the activities are given, and that the scheduling is given. See here, see, A is the initial activity, and after then so many things are given here. A is less than BCD. A is less than BCD means it conveys a meaning that BCD are the activities which come after A, or A is an activity that precedes BCD. That is the meaning of that. And likewise you can read this as B less than E. That means B is an activity that comes before A, or E is an activity that comes after A. That means B precedes and E succeeds. That is the meaning of that. So you see that by this way you are given a scheduling like this. Now, and also it is given at the end that G is the terminal activity. You got to draw the network of this project as per the scheduling here. Okay. Now, after then you will find that the earliest time of start for activity, and also the latest time of activity, earliest start and latest finish of every activity. I will explain everything as I do the problem. You see that after doing all this, I will be able to find out what is the maximum time that is required for completing the project. Okay, so we will find out what is the maximum time required to complete the project, and I will call that as critical path. This is called a critical path method. What I am going to teach you is a critical path method. So you see that this is what I am going to do, and I will come to the rest of the things after drawing the network. So you see that. So what is given here? So you start like this. You start from a node. This is called a node. Node is just an event, a start of an event, or the finish of an event, the start of an event or a finish of an event. Sorry, start of an activity and finish of an activity will be denoted by nodes. By which I mean, you see that I will start like this. Say A is an activity like this. A is an activity like this. So you see that this A is an activity which is 1 to 2. So you see that 1 is a node, 2 is a node, and 1 and 2 are maybe even called as events. So 1 is a node, 2 is a node, and in between what happens is an activity. And as per this, B, C, D are the activities that are coming after A. That means here you see that B, here U, and here you see that C, and this is D. 3, 4, 5. I will write here. So you see that these 2, 3, 4, 5 are the nodes, and 2 to 3 is your activity B, 2 to 4 is your activity C, and 2 to 5 is your activity D. And you must know that here the durations are given. A, for completing A you require 3 days. For completing B you require 6 days. For completing C you require 16 days. But you see that the lengths of the activities are not, the lines are not drawn as per the measurement. It is not. Simply you draw, you show that activity. That length has nothing here. This length, drawing this length has nothing to do with the measurement given in the thing. That is the number of duration given in the problem. It has nothing to do. We just draw this. We show only a network. So you see that A is an activity, B comes after that, C comes after that, and D. And you do not know what type of diagram network you will draw. That means you can simply draw and finally do some adjustment, and see that normally it goes from left to right and converges. If it is, see, the activities has to converge, because there must be a start, means there must be an end. There must be an end, and all activities must go and converge at that end point. You see that? So all activities are interrelated. Try to understand. The activities are interrelated, and there cannot be any activity which is hanging in the air. That cannot happen, because no activity can stand alone. That is, stand alone going away from the network. It cannot do. So you see that all activities are interconnected, and there is a starting node and there must be an end node. So you see that. Let me draw this. So B, C, D. Then he says that B is less than E. That means E is an activity that comes after E. So I will just draw. I will draw this. So this is an activity E. And C is less than F. Where is your C? C is here. So you see that C is less than F. So this is what I am having. And D is less than G. So this is what I am having. This is my G. And E is less than F. E is less than F. So you see that C is less than F, and E is also less than F. So what I do here is, see that this, here it is like this. So you put it like this. Now you see that. So this is an activity C. So I draw the activity C, and I draw the activity E, and you see that F is coming after C, and see, F comes after C and after E. So this is C activity, D activity, E activity, and F comes after C and E. So you have to adjust and draw. See this, there, as in when you draw the network, do some adjustments to get it corrected. No problem at all. F, then you see that F and E and F. D is less than G. See here, D is less than G. D is less than G, and F is also less than G. So what happens is here, so I will draw like this. This is your G. So you see that now you just read this, you will get. So after drawing this, you must be able to read from the network and see whether you have drawn it correctly. Look into the problem. Just read from the network and look into the problem whether this coincides or this reads as given in the problem. So you see that, let me read here. A is B, C, D or greater than A, or A is less than B, C, D. See, A is less than B, C, D. B is less than E. Yes, B is less than E. C and E are less than F. Yes, C and E are less than F. Okay. D and yes, D is less than G. Yes, D is less than G. G and F, see, G is, sorry, this D, it is wrong. See, you just see that I am wrong. So what I will do here is, I will draw like this. Now you see that D is less than G and F is also less than G, and G is the final activity. Now you just read A is less than B, C, D, B is less than E, D, C and E are less than F, correct? Then D and F are less than G, and G is the final activity. So you see that this is a correct diagram. After this, I will just write the node here. So this is the node, and here mark this, you have to put that arrow mark. It goes from left to right. And this is 1, 2, 3, this is 4, this is 5, and this is 6. So you see that here it may look like these two activities are standing. It is not. You see that these two activities are fully connected with the other activities here, and you can find that this goes from left to right, and this is how we draw. And you have to put this arrow mark on every activity here. See, every activity. Now what is that you have to do is, so this is the drawing the network as per the schedule given in the problem. So I have drawn here. After then you have to mark the, we have to get the earliest start time and latest finish time at every activity. So you see that here earliest start time and latest finish time. So these are the two things that we have to get: earliest start time and latest finish time. See, when you go from left to right onward, you go for an onward journey, you see that it must be earliest start time, and when you come back return, it is the latest finish time. And I will tell you how it should be calculated. I will not write everything, because I feel that those who are watching this video or attending this class should have some background about this particular subject. So yeah, I may not write, but fully I will explain the things completely. You just listen and carefully understand what I teach you. Okay, now so you see that when this starts, so when you start the time, it is 0, 0, correct or not? When you start the project starts at 0, 0, and A activity takes 3 days. So he will come to earliest start time of the activity 2 is now 3, correct or not? So earliest start time of the activity is 3. Okay, now let me come to this. See, what is the time for B? B, it takes 6. So I'll write this 6, the duration below the line or above the line. So it takes 6 days for completing the job B. That means here after completing A, it takes 3 days. So after 3 days, B will be taken up. So it runs for 6 days. So you see that for doing E, it will take 9 days. For doing E, for taking up the job E, it will take 9 days. So you see that this is 3, this is the earliest start time. So the earliest start time at 3 for doing the job E is 9. Now similarly, let me do this. Now let me come to this. So you see that what is activity 2 to 4? Your activity 2 to, this is your B, this is your C activity. C activity, it takes 16 days. 16 days. That means what? A will start here at 3. He will do the job C, and also he will do the job B. For completing this job, it's 6 days and it goes to 9. So 9th day he starts E, and at 2 C job is started, and that it takes 16 days. So 16. Now at the node 4, the activity F starts. Now you must know that the F, that is the F job F will be taken, and E I will write here, and this job F will be started. See, you see that this job F will be started after, you see that here after completing B, it takes 9 days. and you have to complete this E to get into F. You have to complete this job E to get into doing the job F. So it will take 9 plus 8, 17 days. But when you come through this 3 days and it takes 2 to 4 completing the job C, it takes 19 days. So at the node 4, 17 days, and there are 2 days available. That means 2 days of start. 2 days of start available. 1 day of start is 9 plus 8 is 17, and another one is 16 plus 3 is 19. When you get into such problems, a dilemma where which one to take, whether to start 9 plus 8 17 days after 17 days or 16 plus 3 after 19 days, which one? Usually when you take up the forward that is forward calculation, when you go for that, you have to take the maximum. That means what? Here you see that here it is, you get see at D4, at 4 you see that it is either 9 plus 8 which is equal to 17 days, or 3 plus 6 that is equal to 19 days. So we can start at 4 the job F either at 17 or 19, but usually you take the maximum, that is the maximum of the length. That means what? Here how you give this is earliest start time of E. So earliest start time of E plus here earliest start time of this, here I will write earliest start time of B. See, earliest start time of B plus see it is T34. Here T34 means the time taken for doing the job 34, and the earliest start time of A, see it is your E, earliest start time of C plus here, sorry, this one earliest start time of here, yes, earliest start time of C plus T24. See, earliest start time at this place plus the time taken for 3 to 4, that is 17 days. So this is equal to 17 days. Then the earliest start time of C is 3 plus the time taken for 2 to 4 is 19 days, which is maximum. So take the maximum of 17, 19, that is equal to 19. So this job, the earliest start time of the job here is 19 days. That means the earliest start time in the previous activity, the start of the activity plus the duration of the time. The earliest time to the start time of the previous activity plus the duration of the time. That is what I have written here. So 17 and 19. So you will start the job at 19. Now, so the same pattern must be followed. So you have to calculate at a particular node junction comes, you have to find out all the that is the start time. The start times, there will be 3 or 4 start times may be coming at a junction. Among all the start times, you have to choose the one which is maximum. Here, as you see here, there are 2 start times. Earliest start times are given. One is 17 and another is 19. Which is maximum? 19 is the maximum. So you will take 19. Now, same way you will come across this one. So you see that for D, for D it is 10 days. For D it is 10 days, and for F it is 5 days, and for G it is 3 days. So you are given. So for the completing time of 4 to 5 F is 5. The completing time for 2 to 5, which is D, it is 10 days. Say I'll write here 10 big here. It is 10 days. It is 10 days. Here it is 5 days. It is 3 days. Now you see that Now you have to come here. Now you do the same thing. What is the earliest start time coming through F? It is 19 plus 5 is 24. But when you come through this is 3 plus 10, 13. So you are getting two earliest start times. You are getting two earliest start times through different directions. So this is in one direction. It is coming from 4 to 5 is one direction. If you come through that direction, the earliest start time at 5 will be 19 plus 5 is 24. So it is 24 through that. And when you come through this direction, that is through D, it will take how much? 3 plus 10 is 30. Now which is maximum of this? It is 24. So you see that 24, that the job G will be taken only after 24 days and not 13 days. You have to take the maximum. That means at a junction means what? Two or more activities merging at that point. So at the junctions, you calculate all the earliest start times through different directions, and among all the earliest start times, you take the maximum when you move forward from the initial to the end point. Okay, now coming to the last one, 27. So this is 20. So you see that the job would be completed in 27 days. Now this is 27 days. So this is your earliest start time, and your latest finish time is also 27. So you see that here your earliest start time. So I will repeat this. 1 to 3 is 3 days. Therefore, the job B will be started only and after 3 days. Likewise, C will be started after 3 days, and D will also be started after 3 days only. And the job E will be started after 6 days. See, 3 plus 6, 9 days. And this job F will be started after completing A, B, E and A and C. That means that is the preceding jobs have to be completed before doing this job F. Now you see that at 4 node, before doing this 4th job, there are two earliest start times that are coming in two different directions. If you come through 2 to 3, 3 to 4, you see that 9 plus 8, 17 days will be the earliest start time at 4, that is starting the job F. But when you come through this direction 1 to 2 and 2 to 4, or A, perform A and then C and come to node D, F, node 4 to do the job F, you see that when you come through the direction 16 plus 3 will be 19 days. So you see that 17 days and 19 days are the two earliest start times that you will get, and you will choose the maximum only, that is 19. That means if you start after 19 days, all your preceding jobs would have been completed. Can you understand? So likewise, the same logic holds here at 5, and you see that it is 24 days, and you find that the job would be completed after 27 days. That is, your earliest start time is 27 and latest finish time is also 27. Now you have to backtrack. That means go backward and find out the latest finish time. Now let us start finding the latest finish time. So here it is 24. Now 27, that means what? You have to subtract. Here you added, now you subtract. 27 minus 3, it is 24. So you see that you will come to this node after 3 days to 24 to do to backtrack. So you see that now here when you come here, it takes how many days? It is 5 days. So 24 minus 5 will be 19. Okay, now if you want to come to this place, now you can come from 4 to 2, and you can straight away come from what? This 5 to 2. Can you see this? See, there are two routes possible. 5 to 2 is possible and 4 to 2 possible. That means this becomes a junction which is the meet of the directions or the paths 4 to 2 and 5 to 2. When you take this 5 to 2 path, it is 24 minus 10 is 14. When you take this path, 19 minus 16, that will be 3. Okay, therefore there are two latest finish times at node 2. They are 14 and 3. How do you get this 14? You can come from 5 to 2, that is one path, that is 24 minus the duration 10 is 14, and from 4 to 2 also you can come, that is 19 minus 16, that is 3 days. So you get two latest finish times 14 and 3. You will choose the minimum. For minimum of 14 and 3 is equal to 3. So this is 3. So you see that you will that is the latest finish time at node 2. And here also there is a problem. You just see that here, before that I will take, see, you have come to 19. Now this 3, there is only one path, so 19 minus 8 is 11. 19 minus 8 is 11. So latest finish time at 3 is 11. So 19 minus 8 is 11. Now coming to this, now you see that I will just take away this. So you see that, see, there are three paths. See, 3 to 2 there is one path, 4 to 2 there is one path, and 5 to 2 there are three paths are there. When you come from 3 to 2, it is 11 minus 6, 5 days. When you come from 3 to 2, 11 days, latest finish time is 11. 11 minus 6 is 5. When you take this road 4 to 2, it is 16. 19 minus 16, it is 19 minus 16, that is equal to 3. So from 4 to 2, if you take, the latest finish time at 2 would be 3. When you come from 5 to 2, the latest finish time will be 24 minus 10, that is equal to 14. So you see that there are three latest finish times that are coming here in 2, because 2 is a junction for 3 to 2 paths, 4 to 2 paths, and 5 to 2 paths. When you come from 5 to 2, you see that it is 24 minus 10, that is equal to 14 days. That means latest finish time is 14 days. But when you come here, 19 minus 16, it is latest finish time is 3. And when you take this 11 minus 6, which is equal to 5, therefore, so among all this, see, this is your latest finish time. This is your latest finish time. There are three latest finish times. You have to choose the minimum. Min of 5, 3, 16, that is 3. So you have to choose 3. Can you understand? So this is 3. Now 3 minus 3 is 0. Automatically you get 3 minus 3 is 0. So you see that this is how we find the earliest start time and latest finish time. You start at 0 and you add the durations of every activity. But you have to be careful when you come to a junction. What is a junction node? It is nothing but 2 or 3 activities meeting at that particular node. If you come across a junction, then you have to take, while you move forward, while you find the earliest start time, then you have to take the earliest start time at the junction, which is the maximum of all the paths leading to that junction. And when you come back, when you find the latest finish time, you will come across the same problem as there would be a junction for which the opposite must be done. In the sense that you calculate the latest finish time at the junction leading to from various paths leading to that junction, and among all the latest finish time, you choose the minimum. This is the law. I am not writing everything because I told you should have some idea on that. That is why I don't elaborately write, but I explain every point with clarity what you should do. Okay. Now, so this is what I have done here. So here again I will just tell you that this 2 is the node. You are coming back from 6 to 2, and when you come back, there is a path 5 to 2, 4 to 2, 3 to 2. Therefore 2 is a junction. Now I told you find the latest finish time at the node 2, coming from 3 to 2, 4 to 2, and 5 to 2. You see that 3 to 2 is 5, 4 to 2 is 3, 5 to 2 is 14. Among all the 3 minimum, that is the latest finish time, choose the one which is the minimum, that is 3. So I have got here. So this is how you draw the network and calculate the earliest start time and latest finish time at every node. Okay, now let us start doing this. Now you see that here you can find that, see, here you can find that there are some nodes. This is a node where earliest start time is equal to latest finish time. Here is a node, this one. See, I will write here. This you can find that it is a node like this. See here, this one, of course this one, and this one. So I have marked with green ink, and you can find that these are the nodes where you can find the earliest start time is equal to latest finish time. And you have to connect all the nodes which have the earliest start time equal to latest finish time. So what I will do here is that I will draw with like this, and it is going like this, and it is taking a path like this. This is your critical path. That critical path, what is that critical path? 1 to 2, 2 to 4, 4 to 5, and 5 to 6, and that is equal to 3 plus 16 plus 5 plus 3, that is equal to 27. So you see that, so it will be 27 days. So you see that you have to, you cannot, that means what? It is just like a plant growing in a soil. See, when you sow the seeds in the soil, you must know that for the plant to grow and give you the fruit, it may take 3 months or 4 months or 5 months like that. Let us and paddy, you see that in 3 months to give you the yield. You have to wait for 3 months. If you are going to just harvest it before 3 months, means what? If you are in a hurry, and if you are hasty to do that, if you are going to just try for the grains within 3 months, you will find the emptiness. So you say there won't be anything. So it should be given. If you are studying engineering complete, you have to read 3 years or 4 years, and then only you will gain that much of knowledge. So everything has got a period to the optimal period to get the best. So you see that here it will take 27 days for this project to get completed. If you try, you can try one way or other. If you are going to employ more people, and if your funds are going to be fast coming, and even the season, that is the climatic conditions and other things assist you, and you are able to get a loan from the bank very easily, something like that. You see that you may be able to finish the project, meaning say some 3 or 4 days before. But if you take the proper scheduling of doing the work as such, you will find that it will definitely take 27 days. So this is the what? This is a critical path, and this is the path of maximum length, and it will take 27 days for you to complete the work. Can you understand? Now let us coming to this. So I have got this. This is what? See, that is you are asked to find earliest start of events, latest finish of events, the total project time. See the total project time. Total. This is the network of the project, and this is the total. It is asked total project time. So your total project time is 27 days. So I have answered the 2 questions there, and you are asked to find the floats. Your floats are nothing but it is meaning of the time advantage that the project that is project manager may take while executing the activities, so that the project duration may not be affected. That means he will try to, because you see that for various reasons you may not be able to start some activities in time, but you must know this, these critical activities got to be started. You cannot delay the activities. I used to give examples in my class that if you are doing an operation, suppose you have got that is some chronic problem, and that you are having a heart problem, something like that. You see that if you have to attend to the most critical thing first. You cannot postpone it. Certain things can be postponed. For example, you see that your operation in the leg can be postponed, but your operation in the heart cannot be postponed. That is a critical activity. So you see that critical activities cannot be postponed. So likewise, you see that here 1 to 2 I have written here, 1 to 2, 4 to 5, 2 to 4, 4 to 5, 5 to 6. They are all critical activities which cannot be postponed. That means what? You cannot take time advantage to postpone for various reasons. If you are going to postpone it, it will lead to a lot of complications, escalation of cost, or delayed in project, and you will not be finish it and give it to your customers. So you see that you will incur a lot of hazards in that way. So you see that we will not do that. So they are all critical activities. So you see that floats are nothing but the time advantage that the project manager can take while executing the activities without affecting the project duration. That is the idea behind this floats. And I will teach you this total float and everything. You see that here, how do you prepare this? I'll prepare this and tell you. So here you see that here it is activity, and duration, earliest start time, finish time, latest start time, finish time, total float, free float, independent float. See, if ST means start time, FT means finish time. This means total float, free float, and independent float. We have total float of I to J. So total float of I to J, free float of I to J, and independent float of I to J. Now let us take one by one. You just see that here you take activity A. It is from 1 to 2. 1 to 2. The start, see, it is 3 days duration. It starts at 0. So 0 plus 3, 0. 3 is 3. It is the earliest start time is 3. And you see that here duration is 3. Earliest start time is 0. 0 plus 3 is earliest finish time is 3. And what is the latest finish time? It is 3. And what is the duration? 3 minus 3 is 0. So let me complete this first. And B activity is 2 to 3. Here you see that the duration is 6 days. Earliest start time is 3. So 3 plus 6 is 9. What is the latest finish time for this 2 to 3? It is 11 days. 11 minus 6 is 5. Then you see what is the C activity? 2 to 4. How many days? It is 16 days. What is the start time? 3. It is 19. What is the latest finish time? It is 19. So 19 minus 6 is 16 is 3. Then D. What is your D here? D is 2 to 5. 2 to 5. What is the duration? 3. 10. Start time is 3, 10 plus 3 is 13. What is the latest finish time? 24. 24 minus 10 is 14. Then E, what is E? That is CDE. E is 3 to 4. And what is the duration? 8 days. What is the start time? 9. 9 plus 8 is 17. What is the finish time? 19. 19 minus 8 is 11. And your F, what is your F? 4 to 5. And what is the duration? 5. It starts at 19. 19 plus 5 is 24. The finishing time is 24. Latest finish time. 24 minus 5 is 19. And then you have got what is called your, sorry, this one, G. G is 5 to 6. And what is the duration there? It is for 3 days. You have got this 3 days. When does it start? 24. 27. So it completes at 27. 27 minus 3 is 23. 24. So you see that this is how. What is, I will explain once. See, for example, what is your C activity? This is your C activity. What is the duration? 3. What is the earliest start time? 3 here. So 16 plus 3 is, your earliest finish time is 19. What is its latest finish time? See, go to the 4th node and find what is the second coordinate? 19, which is the latest finish time. So your latest finish time, take away this time duration, 19 minus 16, that is equal to 3. Come to this 2 to 5. What is the duration? 10 days. When does it start? 3. So 10 plus 3 is 13. What is the latest finish time? Go to the node 5. You find that it is 24. So you see that it is 24. 24 minus 10 is 14. So this is how we calculate this one. And you see that the total float of this activity is, see, total float is equal to, total float of Ij is equal to earliest start time minus earliest finish time of I to J. What is that earliest start time? Earliest start time minus latest. Here it is earliest start time minus latest last start time. Earliest start time minus latest start time. So this is the formula. See, what is that? T, total float of I to J is equal to earliest start time minus latest earliest start time. Earliest start time, it is earliest start time, latest earliest start time, earliest finish time, latest start time. It is latest start time. Earliest start time minus latest start time. That means, see, earliest start time, here it is. Here you see that earliest start time. This is on. So earliest start time minus this. 3 minus 3 is 0. Come to this. 3 minus, see, it is latest. 5 minus, it is, I will put it like this. Latest start time minus latest start time minus earliest start time. That means here you see that it is 5 minus 3 is 2, 11 minus, see, this minus this minus, that is 2. 19 minus 19 is 0, 3 minus 3 is 0. Then you see that this is this one and this one. 14 minus 3 is 11, 24 minus 13 is 11. Come to this one. 11 minus 9 is 2, 19 minus 7 is this is 2. And likewise 19 minus 19 is 0, 24 minus 24 is 0. 24 minus 24 is 0, so this is 0. So this is what we have. Now you see that another thing I will write here. Then free float I to j is equal to total float I to j minus I, that is L minus E at I at j head. At head I am writing. What does it mean? You see that what is your coming to this, take this, what is your total for this? I am going to find the free float. What is your free float here? Free float of I to j is equal to total float of I to j minus, I will write here, slack at head, that is j, that is j, that is at j. See here, you see that come to this, what is the total float here? 0. Come to the head, 1 to 2 is your head, 2 is your head. Slack means subtraction of the latest and finish times. This is your earliest start time, latest finish time, subtract one from the other. So 3 minus 3 is 0. So I will write here. So you see that this will be 0. Come to the next one. You see that here the total float is, here it is total float is 2, and come to the head. What is that? 2 to 3. Here 3. So you see that difference is 11 minus 9 is 2. 2 minus 2 is 0. So I will write here only for this. See, free float of B is equal to free float of 2 to 3 is equal to total float of 2 to 3 minus L minus E at 3. So this is equal to, it is here, see here it is 2 minus 3 minus 3, that is 2 minus 0, that is equal to 2. So this is how we calculate. So now come to this 2 to 4, 2 to 4 is 0. Go to the fourth node, you find L and E to be 19, 19. 19 minus 19 is 0, so you will get this to be 0. Come to this, so I have completed this, 2 to 4, 1 to 2, 2 to 4 I have done. Come to 2 to 5, 2 to 5, what is your 2 to 5? It is 11. So 11, fifth node, where is your fifth node here? Fifth node is here, 2 to 5. 24 minus 24 is 0, so you get this 11. Come to this 3 to 4. What is the 3 to 4 here? You get 2, and fourth node, it is 19 minus 19 is 0, so you get to be 2. Come to a 4 to 5. Your 4 to 5 is here, so what is the total float? 0. At 5 you have got 24 and 24. 24 minus 24, use this formula, so it gets 0, so it is 0. And he will find that this is also 0. So you see that the free float, I will repeat this, free float of the activity I to j is total float of the activity I to j minus slack at head. Slack at head means at the node j, what is it? At the node, end node j, you subtract the latest, earliest start time from the latest finish time. For example, you see that if this is the head, take away this, 11 minus 9 is 2. That is the meaning of that. Now, so using that, you can, so I have given you the formula for what? Total float, and this is a free float. And coming to this one, I will write here. See, I will write independent float. Independent float is IF of I to j is equal to free float of I to j minus L minus E at tail. that is equal to free float of I to j minus L minus E at I. Now come to this, free float is 0, come to this first node, tail node 0, so this is 0. Come to this 2, it is your 2 to 3, it is free float is 2, come to the tail, 3 minus 3 is 0, so it is 2, and it is 0, 0 minus 0. Come to this 2 to 4, what is the free float? 0. 2 to 4, it is 3 minus 3 is 0. Then come to 2 to 5, it is 11. What is your 2 to 5? It is here. It is 11 minus, at tail it is 3 minus 3 is 0, so 11. Come to this 3 to 4, your 3 to 4 is here, its free float is 2, come to the tail, 11 minus 9 is 2, 2 minus 2 is 0. Come to 4 to 5, your 4 to 5 is here, free float is 0, come to the tail, 19 minus 19 is 0, it is 0. Come to the last activity, it is 0, free float is 0, and at tail it is 24, so 24 minus 24 is 0, so 0 minus 0. So you see that I am using this. So what is the formula? So this is the total float formula, this is your free float formula, and this is your what? Independent float. So this is your independent float. So I told you it is a time advantage. Now you can very well see that this A is a critical activity, 2 to 4 is a critical activity, 4 to 5 is a critical activity, and 5 to 6. So you see that for this all the floats are zeros. See, all the floats are zeros. So I told you no. That means if you say that they are critical activities, you cannot delay that activity. You cannot postpone that activity for any reason. If you are going to postpone that activity, you will end up in problems as financial constraints, or it will be very much delayed, or that lot of you will face lot of problems. It will be you should not postpone it. They are all critical activities. Suppose you see that when you are constructing a building, you are supposed to put the ceiling. Let us suppose that you postpone putting the ceiling on the building. What will happen? Suddenly rains or something happens. You see that the whole building will be spoiled, and you have to incur more expenditure. So that is a critical activity. Foundation is a critical activity. Ceiling is a critical activity. And see, there are certain activities which are very critical. So you have to necessarily do that. If you don't do that, it may lead to unexpected unexpected complications, unexpected expenditure, or very much delay. You do not know what will happen. Okay, so you see that is why you find that means these zeros very clearly indicate that you cannot take time advantage. Floats or 0 means no possibility of taking time advantage to perform that job. Okay, now I will finish off with this thing. So you see that this 2 days merely means that this 2 days total float for 2 to 3, it means that you can postpone that activity, or you can delay that activity by 2 days. Still the project can be completed in 27 days. That is the meaning of that. And here you find that here free float is 11 days. That means what? You can your start of the activity may be delayed by 11 days. Still your succeeding activities will not be affected. Can you understand? The start of succeeding activities will not be affected. That is the meaning of that. Now come to this. So when you see here also the same thing. By chance you are getting here 1 day or something like that. Independent float some numbers. It means that you can delay that activity by so many days, but still your succeeding activities will not get affected. Can you understand? So you see that these are the importance of this floats, and total float plays an important role. It merely tells you that it talks about the critical activities, and it emphasizes on the critical activities to be finished in time, and some of the activities, like if you take a building, painting work can be delayed, even electrical work can be delayed. Yeah, all these things can be delayed, but foundations and this one ceiling and the rest of the things are very, very important, which got to be done in time, otherwise you will get into. So this is the network of the project, and this network clearly tells us that the duration on how many days it has to be finished. It gives us the maximum time for completing the project, and it also talks about the critical activities that are involved, and also some of the activities which can be delayed, and also it gives you actually the time by which you can delay the activities, so that sometimes the preceding activities may not get affected, and in some cases succeeding activities will also not get affected, and the project can be completed in time. So this is all about this deterministic network scheduling problem. Okay, let us see the other things in the next class. Thank you.